Okay, the next thing that we want to cover on quantities is a concept called molar mass. Now, in the last note, we talked about the number of moles, and um, now we want to know what is the mass of a mole of something. And there's a number of ways we can figure this out. Well, first of all, let's start with the definition. Molar mass is given the symbol capital M. And so the mass of 1 mole of an element or a compound is simply what we call the molar mass. An example, if I have an atom of copper, up till now we've looked at it as 12U, 12 atomic mass units. Well, it turns out that that number that we have on the periodic table, if you look up under the legend what that value is, it actually says molar mass instead of atomic mass. And so how we see that number then is that it's the mass of 1 mole of a substance. The atomic mass is the mass in atomic mass units of one atom. But it happens to be also the mass of 1 mole of the substance in grams. So we use that same number for both of those types of quantities. So every element has its own molar mass, and we use that molar mass to convert the number of moles to mass and vice versa. So here's how the calculations work. First of all, the formula is the mass is equal to the number of moles times the molar mass. Usually it's written out in this way, m equals capital M times n, or sometimes lowercase n. The m and the n, the capital M and the n are reversible, obviously. The order doesn't matter. So the lowercase m is the mass. That unit is in grams. The capital M is our molar mass. And this unit is grams per mole. And then we have the number of moles, which we already talked about. All right, so if I have, let's say, half a mole of sulfur, what's going to be the mass of that quantity? So I'll use my mass is equal to 32.06 grams per mole. I get that off the periodic table. Look that up. And I'm going to multiply that by the number of moles, 0.5. And so that's going to give me 16.03 grams as a mass. Now, because we had only 2 significant digits in our question, we need to round this number to 2 significant digits, so that becomes 16 grams. Another example. How many moles are present in a 10 gram sample of iron? So this time we're looking for the number of moles. So we're going to rearrange so that n is equal to lowercase m over capital M. 10 grams divided by 55.85 grams per mole. Again, that 55.85 grams, we get that off the periodic table. That works out to 0.17905, 1029 grams, number of moles of iron. And again, we have to round to, in this case, because it's 10.0 grams, we're going to use 0 grams. We're going to use 3 significant digits. So that means we're going to round this to 0.179 moles. Now, how do we deal with compounds? Because they're a little bit different than the elements. However, it's not too far of a stretch because the compounds are made up of elements, right? So we just got to figure out how many of each of the atoms are in a compound, and then we can use that to figure out what the molar mass of that compound is. So, find the molar mass of aluminum nitrate. So we have aluminum nitrate here, AlNO3, 3. There's 1 aluminum, and its molar mass is 26.98 grams per mole. And we have 3 nitrogens, each one is 14.01. We We have 9 oxygens to give us 144 grams per mole. And then we just add them all up. Gives us a total of 213.01 grams per mole. Remember, with addition, we keep the number of decimal places. Now, your periodic tables have 3 decimal places on the molar masses from the periodic table, and so your answer here would have three decimal places instead of just the 2 that I've got in my note. I was using an old periodic table when I made up this note. Okay, finding the molar mass of sulfuric acid. This is done as an example. Spend a few seconds, do the calculation. Put my video on pause while you're doing it. I'm just going to move along just to shorten the video. And we get 98.08 grams per mole. Try this one, N2O5, dinitrogen pentoxide. Again, pause me here. You should get 108.02 grams per mole. Third example, magnesium iodide. Pause me for a few minutes while you figure it out. You should get 278.11 grams per mole. Okay, so it's fairly straightforward. Try this from your textbook. Actually, just before we do that, let's go and review some of this. So here's the relationship between mass and moles. So if we go from mass to moles, we divide by the molar mass. Going back the other way, we multiply by the molar mass. We have to go through moles for these conversions. So molecules to moles, we use Avogadro's number. And then for atoms to molecules, it's just a matter of counting. If we go moles to atoms or atoms to moles, we use Avogadro's number again. Remember, Avogadro's number has to do with particles. Those particles could be either atoms or molecules, depends on what you're talking about. Last thing then is that if you're going from molecules to atoms or atoms to molecules, then you just count. All right, so spend some time working through some of these problems. The more you do, the better you'll get. Some of you will need to learn this well. These are the questions related to that from your textbook. I'd say maybe start with doing 3 or 4 from each page, and then if you're still not having a lot of success with that, come to the chat, ask some questions, and then try some more. Okay.